The paper we're going to take a look at today is Comparative Analysis of Root System Morphology in Tomato Rootstocks by David Suchoff, Christopher Gunter, and Frank Laus. First off, when you're looking at rootstocks of tomatoes, the reason that they pay so much attention to the rootstocks is for grafting. It's a common practice in horticulture when you're growing a variety of tomatoes that's highly desirable to the market, but it has issues with diseases or not having drought tolerance and other stresses, is to actually graft it onto the rootstock of a much more tolerant plant. So the top part of the plant, the scion, is the part that still grows the variety of tomato you want, but the bottom is roots that belong to a plant that can handle disease stress and can handle water stresses. So what they wanted to look at was, are there morphological differences? Are there physically noticeable differences in the rootstocks of these different tomatoes that can help account for the better disease resistance or the better morphology links to drought resistance? The reason they wanted to do this also was to validate the ability to grow these to evaluate the roots inside of an actual solid media. You could grow them in hydroponics, but you get very different root morphologies when you have a saturated system like that than you would growing them in the ground. For this experiment, 2 grow times were used. There was an October-November one and a November to January grow time, so we have 2 different time frames. There were 17 rootstock cultivars, so ones that are known for being used as rootstocks and grafting, and 1 common determinate tomato cultivar, one you wouldn't expect to use for grafting. It's your everyday tomato. These were grown in 6-inch pots with 1 plant for each cultivar, and also 1 pot per harvest date. There was a 2-week, a 3-week, and a 4-week harvest date from emergence. So what this left you with is 1 plant for each cultivar for 2 weeks, 1 plant for 3 weeks, and 1 plant for 4 weeks. After these were grown and pulled at 2 weeks, 3 weeks, and 4 weeks, the plants were cleaned by hand. They were carefully sifted with brushes to not damage the roots. And then they were stained and scanned on a flatbed. They were floated in water so that none of the roots overlapped, and the computer could scan them. And they were put into an image analysis system. A quick note on what they were grown in. They were actually grown in a special media that was predominantly sand with soil conditioner, a clay soil conditioner added to it, so they could be easily removed. Statistically, they ruled out any interactions, experiment via treatment, cultivar via harvest date, and they found that there wasn't really a noticeable difference in 2-week, 3-week, and 4-week. I mean, they were longer. You would expect them to be being grown longer, but they weren't different, anything strange that you wouldn't expect. So they went ahead and lumped them together so that they would have a 3 plant per cultivar for statistical analysis. So they looked at the total root length, the root diameter, and then the specific root length, which kind of measures surface area. And what they found was the different cultivars had differences. Not surprising. Statistical differences. And the ones that are known, Millefort and Beaufort, which are really known for being used as rootstocks and graftings, tend to have a better specific root length, which would be indicative of drought tolerance. They also had a better total root length. Total root length is a really good way to determine how well they're going to be able to find water in drought conditions, because the roots are longer, they can go further. They can also are more likely to find nutrients because they can cover more surface area if they're longer. So this study managed to verify that the imaging system that they used worked. It verified that you could in fact grow them in a more solid media in order to look at roots. And they also did find the morphological differences they were looking for.